Hello and welcome to Math with Mrs. Becker. Today in calculus, we are going to look at the start of section 8.2, where we just continue to go over some trig basics. Before we jump into this, I really think the big focus should be right here, okay? When you have a right triangle, it's important right away that you realize a right triangle has a 90-degree angle. The two sides that create the 90-degree angle, those are called the legs of the triangle. When you're doing the Pythagorean theorem, which you will end up doing some here, this can be A or B, this can be A or B. The side across from the 90-degree angle is always the longest side. It is called the hypotenuse. In the Pythagorean theorem, the hypotenuse must always be a C. When we are working with right triangles, talking about trig, you probably remember the phrase SOHCAHTOA. And what that helps you to do is identify a ratio, which is a fraction. The way that it helps you is it helps us to figure out the sine of the angle, the cosine of the angle, and the tangent of the angle. So sine is the opposite over the hypotenuse. That's how this helps. Sine, opposite, hypotenuse. The next one, the cosine, is the adjacent over the hypotenuse. So adjacent over hypotenuse. The tangent is opposite over adjacent. Then in college trig, we talked about how we actually have 6 trig ratios. We don't just have the sine, cosine, and tangent. Each one of those has a reciprocal function. The cosecant is the reciprocal of the sine. So that is the hypotenuse over the opposite. The secant is the reciprocal of the cosine. So that is the hypotenuse over the adjacent. The tangent has a reciprocal. The reciprocal is the cotangent. So that is the adjacent over the opposite. Now, when you are trying to figure out which side is the adjacent and which side is the opposite, because we know the hypotenuse has to be across from the 90, you will look and see where theta is. Theta will be one of your acute angles, meaning not your right angle, one of the other two. So if this is theta, if you draw an arrow from the angle, it points to the opposite. Across from the 90 is the hypotenuse, so that would make the third side adjacent. So let's go ahead and use this. It may sound weird, but I want to do the second example first because I feel like it's a more basic example than the top one, okay? So here is my triangle, and I'm going to go ahead and just write it here. That way I can write it a little bit bigger. So notice this is where theta is. We have a right triangle where we're missing a side. That's why it was important to realize in the Pythagorean theorem what would be A, B, and what would be C. These two sides could be A or B. So I could say 4 squared plus 7 squared equals C squared because we're missing the hypotenuse. 16 plus 49 equals C squared. 16 plus 49 is 65. Now to cancel a power of 2, you take the square root. If I tried to break this down to simplify it, I would have 5 times 13, so I could not simplify it. That means that the square root of 65 is simplest form. What they want us to do is find all 6 trig ratios. So if I draw an arrow from theta, it's going to point to the opposite. If I draw an arrow from 90, that's the hypotenuse, so that means the third side is the adjacent. To find all 6 trig ratios, the sine of the angle. Sine is opposite over hypotenuse. So it's 7 over the square root of 65. I cannot have a square root on the bottom. So I go ahead and rationalize the denominator. This would be 7 square roots of 65 over 65. Now the cosecant of theta is the reciprocal of the sine. So if the sine was opposite over hypotenuse, the cosecant is the hypotenuse over the opposite. So square root of 65 over 7. The cosine of theta, cosine is adjacent over hypotenuse, so 4 over the square root of 65. rationalize the denominator by multiplying both top and bottom by a square root of 65. 4 square roots of 65 over 65. The secant is the reciprocal of the cosine. The cosine was the adjacent over the hypotenuse, so the secant is the hypotenuse over the adjacent. The tangent of theta, tangent is opposite over adjacent, so 7 over 4. The cotangent is the reciprocal of the tangent, so instead of opposite over adjacent, it's adjacent over opposite. So that's a basic one. Now the other idea, it's very similar, but what they want you to realize is that if you have a terminal side, remember on an angle that's in a coordinate plane, the terminal side is the side that rotates. If you know an ordered pair that's on that terminal side, you can use that ordered pair to create a right triangle. It will always use the terminal side as well as the x-axis. Okay, so again, I'm going to go ahead and draw this out. They're telling me, I know it's on a coordinate plane, they're telling me that I have an ordered pair at negative 4, 3. So 1, 2, 3, 4 to the left, 1, 2, 3, that's where my ordered pair is. Here is the terminal side. You can use the line that goes through that ordered pair and always the x-axis. It can't be the y-axis. One of the rules, it has to be x. Theta is always next to the origin. Now here, because this is negative 4 and 3, from here, this distance is negative 4. The reason why I can have a negative measurement on the triangle is because it's within the coordinate plane. If you're going to the left or you're going downwards, your side measurement will be negative. If you're going to the right and you're going up, it's going to be positive. The hypotenuse, this measurement will always be positive 100% of the time. Okay, so this was left 4, that's why it's negative, up 3, so that's positive. This is my 90-degree angle, so these are the two legs. So it's 3 squared plus negative 4 squared equals our hypotenuse squared. 3 squared is 9, negative 4 squared is 16 equals c squared. 9 plus 16 is 25. Take the square root of each side. Square root of 25 is 5. Again, theta must be next to the origin. Across from theta, that is the opposite. Across from 90, that is the hypotenuse. The third side is the adjacent. So sine of theta. Sine is opposite over hypotenuse. The cosecant of theta is the reciprocal of the sine. So if the sine is 3 over 5, the cosecant is 5 over 3. The cosine of theta, cosine is adjacent over hypotenuse. The secant is the reciprocal of the cosine. So if the cosine is negative 4 over 5, the secant is negative 5 over 4. Your tangent. Tangent is opposite over adjacent, so it's 3 over negative 4. The cotangent is the reciprocal of the tangent. So it would be negative 4/3. And that is the beginning of 8.2. Just knowing that when you have a triangle, not on a coordinate plane, all of the measurements are going to be positive. Once that triangle is through a point and you're creating it using a terminal side and the x-axis, it's possible to have the legs of the triangle negative depending on the location. You need to know all 6 trig ratios. Now your assignment, this is not an optional assignment for this section. You are turning in your books to page 401 and 402, 1 through 10 all. The book says to find just the sine and cosine. I am asking you to find the sine, the cosine, and the tangent. So you will find the basic 3 trig functions for each triangle. And that is it for today's lesson. I hope you enjoyed our time together, and I'll talk to you soon. Bye.